Here we have to solve for x in the given exponential equation. Okay, in the given exponential equation, there are two terms which contain x and the variable x as the exponent. So whenever in an exponential equation, there are two terms which contain the variable as the exponent. So maybe we can keep one of the terms on the left side, the other term on the right side. So for that, we have to get this negative 2 to the x power. So for that, I have to subtract 2 to the x power on both sides. So to get rid of the negative 2 to the x power. Okay, let me add 2 to the x power on both sides of this equation. So when I do so, this negative 2 to the x power, positive 2 to the x power cancel out. I get 5 to the power x negative 1 is equal to 2 to the power x. Okay, here, so I'm trying to solve for the variable that is at exponent. So whenever we are trying to solve for the variable that is at exponent, so what we need to do is we have to get the same base on both sides of the equation. So is it possible to get the base 2 on the left side over here? Because on the right side we have base 2. So if it is possible, we can get base 2 on the left side. For that, this 5 has to be a power of 2. But actually 5 is not a power of 2. Anyways, shall we try to get this base on the right side as 5? Because we have base 5 on the left side. So we should try to convert this base 2 to 5. For that, 2 has to be a power of 5. But that is not that is also not possible because 2 is not a power of 5. So I don't think I'll be able to get the same base on both sides of this equation. So to solve this kind of exponential equations, we have the only option logarithm. That is, we have to use logarithm to solve this exponential equation. So for that, what I'm going to do is I'm going to take a common logarithm on both sides. What is meant by common logarithm? A logarithm with base 10 is called common logarithm, because when you take common logarithm, that is with base 10, so easily I can get values for the common logarithms using a regular calculator. Okay, now let me take a common logarithm on both sides. So log 5 to the power x negative 1 to the base 10 equals to log 2 to the power x to the base 10. Okay, I've taken common logarithm on both sides. So here I can use the power rule of logarithm. So what is it? So here the argument is exponential. So whenever the argument is exponential, so the exponent over here in the argument of the logarithm can be moved in front of the logarithm. So then it has to be multiplied by the logarithm. This is the power rule of logarithm. So now I'm going to move this exponent x negative 1 in front of the logarithm. Further, this x negative 1 will be multiplied by log 5 to the base 10 equals to the same thing. Here the exponent x can be moved in front of the logarithm. So then x times log 2 to the base 10. Okay, now what we can do is I can distribute this log 5 to the base 10 to this x and log 5 to the base 10 to this negative 1. So when I do so, I'll be getting x times log 5 to the base 10, and log 5 to the base 10 times negative 1 will be negative log 5 to the base 10 equals to x times log 2 to the base 10. Okay, let me write the same equation over here. X times log 5 to the base 10 negative log 5 to the base 10 equals to x times log 2 to the base 10. Here we are trying to solve for the variable x, but the variable x appears on both sides of the equation. So it has to appear on only one side of the equation. So for that, we can get rid of the variable on the right side. For that, I have to subtract x times log 2 to the base 10 on both sides. So this positive x times log 2 to the base 10, negative x times log 2 to the base 10 will cancel out. I get x times log 5 to the base 10 negative log 5 to the base 10 negative x times log 2 to the base 10 equals to 0. Actually, this term does not contain the variable x. So whether we can get this term to the right side, for that I have to add log 5 to the base 10 to both sides. So when I do so, this one will cancel out. I get x times log 5 to the base 10 negative x times log 2 to the base 10 equals to, we have log 5 to the base 10 on the right side. Now we can factor x out from these two terms. So if I factor x out, I'll be getting log 5 to the base 10 negative log 2 to the base 10 equals to log 5 to the base 10. Okay, to solve for x, I have to get rid of this stuff which is multiplied by the x. For that, I have to divide both sides by log 5 to the base 10 negative log 2 to the base 10, the same thing. So log 5 to the base 10 negative log 2 to the base 10. Okay, here this stuff will cancel out. Okay, let me continue over here. Okay, here we just have x left on the left side, and on the right side we have log 5 over log 5 to the base 10 negative log 2 to the base 10. Okay, we can use our calculator to get the value of log 5 to the base 10. So it's 0.6990. Actually, it is rounded to 4 decimal places. The value of log 5 to the base 10. So here again, we have log 5 to the base 10. The same value we can plug in over here. And the value of log 5 to the base 10 is 0.3010. So this is also rounded to 4 decimal places. Then we get x equals to 0.6990. So when I simplify this subtraction, I'm getting 0.398. So when I divide these two values, I'm getting 1.7562, and it keeps going. So when I round it to nearest hundredth of this value, I'm getting 1.76. So the approximate value of x in the given exponential equation is 1.76.